In question 1, the numbers 1, 2, 4, 7, 8, 9, 10, 11 and 12 are put into a Venn diagram. We're told that number 3 is in set Q but not set P. The number 6 is in both set P and set Q, and we're asked to complete the Venn diagram. We're reading this information here. The number 3 is in set Q but not in set P, would go in this section here. It's outside the circle for P and inside the circle for Q. The number 6 is in both sets, that goes in the overlap. The only thing to do now is to check that all of these numbers we're given are placed somewhere on the diagram. So I can see 1, 2, 4, 7, 8 is there, 9, 10, 11 and 12. So I've completed it. The student chooses at random a number in the completed diagram. We want the probability this number is not in set Q. Note there are 4 elements in set Q. Count how many are not in set Q. That's 1, 2, 3, 4, 5, 6, 7 that are not in set Q. Out of how many numbers altogether? Well, we've got those 7 plus these 4, 7, 8, 9, 10, 11. So 7 out of 11 the numbers are not in set Q. In question 2, our universal set is all odd numbers less than 30. Then we have set A, 3, 9, 15, 21 and 27, and set B, 5, 15, 25. To put these into the Venn diagram, first of all let's label A and B. And we can start by, in the overlap for A and B, identify any numbers that occur in both sets, and we've got the number 15. And then have a look at what other numbers are in set A. 3, 9, 21 and 27. These need to go in here. And what numbers are left in set B? And we've got 5 and 25 in here. Now we need to check if there's any other numbers in the universal set that are not included in A and B but must go on the outside. So odd numbers less than 30, we'll start counting out. Well, 1, we haven't included it yet, so it goes in there. 3, 5 we've got. 7, 9 we've got. 11 we haven't, so that can go outside. 13 goes outside somewhere. 15 we've got. 17 needs to be outside. 19, 21, we haven't got 23. 25 we've got, 27 and 29. Okay. A number is chosen at random from the universal set, and we want the probability that the number is in the set A union B. So let's have a look at how many numbers are in the set A union B, which is all of these numbers that we can see here in both sets. So we count out what we can see inside A union B. You can just put a circle around that. So I'm looking at all of these in here. I've got 1, 2, 3, 4, 5, 6, 7 numbers within A union B. Out of how many altogether? 7, it should be 15, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 odd numbers less than 30. So in question 3, we're given a Venn diagram with all of the numbers already placed. We just need to identify the numbers that are in set A union B. So A union B is everything that is in A and B, just all the numbers we can see once. So we've got 15, 12, 18, 10, 14, 16. We'll pull those numbers that you can see down just once, it doesn't matter if they're in order or not. Okay, next A intersection B, we're looking at the overlap for the two circles, so it's just the numbers 12 and 18. Next, one of the numbers is chosen at random. We want the probability of the number is in set A dash. This means not A, so this is the probability that it's outside of the circle of A. So we've got 1, 2, 3, 4, 5, 6, 7 numbers that are outside that circle. Out of those 7 plus 8, 9, 10 numbers altogether. So 7 out of 10, 0.7, 70%. Okay, that's the probability the number is not in set A. In question 4, we've got a partially filled Venn diagram. 50 students are asked if they have a dog or a cat. 29 have a dog, 30 have a cat, 8 have a dog but not a cat. So to complete the diagram, first of all, have a look. We've got an 8 in here already, and that is where it says dogs. They've got a dog but not a cat. So that is this information here. 8 have a dog but not a cat, already shown. But then go to 29 have a dog. So in the whole of that circle, it needs to add up to 29. That means there must be 21 in the middle. Then 30 have a cat. So in the whole of that diagram, that circle for cat, there must be 30 altogether, which means there must be 9 outside. Now add up how many there are altogether shown already in the diagram. 21 plus 9 plus 8 is 38, but we've got 50 students that have been asked. So if there's 38 shown in the diagram and 50 altogether, there must be 12 outside. 50 minus 38. The student is chosen at random. We want the probability they have a cat and a dog. So how many have a cat and a dog out of how many altogether? So how many have a cat and a dog is 21 in the overlap. Out of how many altogether, there were 50 students that were asked. In question 5, 100 students asked in a survey whether they use text or social media, and we're given this information. Read it really carefully, it's worded slightly differently to before. 35 students said they only use texts, so i.e. they don't use social media as well. They only use text, so we can put that straight into that section there, within the text, but not in the overlap. 29 students said they only use social media, so that can go in there. And 21 students said they use both, so that can go in there. Check now that we've got everybody. When you add up 35 plus 21 plus 29, that comes to 85. We've got 100 students in our survey. There's 15 that aren't shown in there. They must be on the outside here. Part B. One of the students is chosen at random and we want the probability they use social media. Social media is this whole circle here. It includes those that text as well. So it includes the 21 plus the 29. So 21 plus 29 gets us to 50. And we want the probability though, so it's 50 out of how many altogether? 50 out of 100, and I can cancel that down to 1/2. So in question 6, Wendy is at the fun fair. She has a go on the hoopla and a go on the coconut shy. On the hoopla, she either wins or she doesn't. The probability that she wins is 0.4, so that she doesn't is everything else. It must be 0.6. Wins or doesn't must add up to 1. Go on to the coconut shy. The probability that she wins is 0.3, so that she doesn't is 0.7. That's regardless of what's happened at the hoopla. So if she wins on the hoopla, it's 0.3 and then 0.7 on the coconut shy. But if she doesn't win on the hoopla, it's the same thing. It's 0.3 that she wins on the coconut shy and 0.7 that she doesn't on the coconut shy. Part B. The probability that she wins at hoopla and at the coconut shy, well, this and here tells us to multiply when we're in probability. We're going along the branches. Anytime that we go along the branches, we multiply. So wins and then wins is 0.4 for winning at the hoopla, multiplied by 0.3 for winning at the coconut shy. So it's 0.12. 4 3s are 12. Check, so 0.4 times 3 would be 1.2. 0.4 times 0.3 would be 0.12. This could be a non-calculated question. In the challenge, we're given this information and we need to draw a Venn diagram for it. We're given a universal set, a set A, and then we're given some information about intersection with B and union with B. So I know that there's a universal set, set A and set B. So first of all, I would draw my rectangle for the universal set and two circles or ovals for set A and set B. Then label set A and set B, the universal set here. And now we can start filling in. First of all, I would fill in A intersection B in this overlap, 3, 9 and 12. Then from A union B, we would expect to see 3, 9 and 12 appearing in here. And which we do there, 3, 9 and 12. But I can't tell from that bit what goes in A and B. So back up to here, set A is multiples of 3. They have to be multiples of 3 that appear in the universal set. So we've got 3, 9 and 12 already in the overlap for A. I need to pick out all other multiples of 3 from the universal set. So I've got 3, I've got 6 needs to go in here, 9, 12 and 15 needs to go in here. So for set A, 3, 6, 9, 12 and 15 from the universal set, from set A. Moving into A union B, I can now pick out the numbers that I've not yet included from here. So I had 3, I've got 6, 9, 12 and 15 already covered in set A. For the other elements in here are 1 and 2, they must be in here. 7, 10, 11. And 14. Now I need to check that I've got everything in my universal set. Anything that is missing needs to go around the outside. So just along the universal set, this is all of the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all of the numbers from 1 to 15. Let's just check that any that we haven't yet put in go on the outside. So 1, 2, 3, 4 is missing, goes outside, 5 is missing, 6 is there, 7, 8, 9, 10, 11, 12, 13, 14, 15 and we're finished.